Hey, my AP Stats class. I could not be here with you on Wednesday, so I'm going and taping the lesson ahead of time, and I'll post it to all 3 classes just so everybody has it. But I just want to tell you that this is test review day for chapters 2 through 4. So we're going to go over the homework on histograms in the FRAPI very briefly. I'm going to give you an askuethescript.org lesson, which is fantastic, and I've got the video posted, the YouTube video. It's 10 minutes long. I highly recommend you watch him. Then we're going to talk about the Desmos activity that builds off of this skew the script, and it's about police use of force, and I think it's a fascinating study. Then I want you to complete the look back chapters 2 through 4 worksheet, and the important stuff on this is the quantitative data. This skew the script is qualitative or categorical, and quantitative is really the important thing on this one. And then you're going to have a test as homework. So I'm going to let you study your classwork, your homework, your quizzes, your notes, and your reading assignments. The test will be in Mastery Connect. You may do your own work, but you cannot use any outside sources other than your notes. So don't look things up on the internet if you're confused, and don't call a friend. There's also a free response part in that test, and I just want to show you where that is. So right down here is the free response. So it's 2 questions and there's multiple parts per question. So please don't do this and turn it in until you've actually worked all the worksheets. So the free response is also part of the test. Don't just say, oh, you told me the Master Connect was part of the test. I should go ahead and write that as well. Free response. It's in Mastery Connect and a free response worksheet in Google Classroom. All right, so without further ado, let's first talk about this. Something about shape and distribution. So as I was grading your FRAPI, some of you said they were symmetric and some said they weren't. And honestly, there's no wholly right answer. I did see skews in one graph and somewhat symmetry in the other, but when you guys told me you thought there was symmetry in both, I thought, well, I could kind of see that. So there's no one right answer, but be prepared to work with the data that you just categorized as symmetric and give me a mean instead of a median. There's a lot of judgment and interpretation, so just keep that in mind. I'm not saying there's no wrong answers. I'm saying some answers are more right than others. So when we went over these histograms, I noticed a lot of you were getting them wrong. And I think what happened was you didn't notice, okay, so if I see 2 50s, I'm going to look at a graph where the median appears to be at 50. Well, this one does. This one could be. This one probably is. This one might be. This one might be a little higher than 50. And this one's definitely right at 50. So I can't use the 250 mean and medians to give me any information for graphs 2, 3, and 6. So I need to move on and first try and get the ones that are skewed. So if the mean is 60 and the median is 50, that means we should be looking at a skew where it's high on the low side and it goes like this. So that would be this scenario. So we need a skew that goes to the right. Well, somebody drew there, so I'm going to try and draw mine. This one kind of goes right. This one kind of goes, I don't know, that one's sort of hard to say. This one goes to the, skews to the left, obviously. This one is bimodal, and so you can't say it skews left or right. This one looks like it's kind of symmetric, and this one skews right. So between the 2 that are the mean is 60 and the median is 50, I have 2 that skew right. So one could be up here, or it could be here, and that's tentative. But then I say, well, let's look at the standard deviation, because there's another one that skews that way. There's a 53 and a 50. Those are kind of close to those numbers, but this one has a much bigger spread. So if I look at these numbers, I'm somewhere around 10 to 120, and here I'm 35 to 85. 10 to 120 is much more spread out. So I would say, oh, the spread tells me this one is not 1, but 4. And that means the other one must be 1. Okay, so I've got 2 of them knocked out. So that's what you are supposed to do. You're supposed to actually talk about them and see which ones. It's very difficult when you don't have a calculator to plug all this in and get the answer. You have to use your brains. And then here, there's more of them we could have done, but I think I'm going to pause on that. And here, there's some more we could have done, and this is with box plots, and we'll do box plots when we get to box plot chapters. So what I want to do today is talk about this skew the script analysis. And they did this really very timely, very succinct study on, is there a relationship between police use of force and race? And that is all over the news right now. So that's something to think about. So what they did is they did marginal and conditional distributions in a two-way table. Then they did a bar plot. Then they did a segmented bar plot. And then they described associations. And that's where you say, is it independent or not? So associations is it independent? Okay, so let's move on. So first he talked about the stop and frisk policy. And if you don't know what it is, I highly recommend you look it up. I thought I knew what it was and I was a little bit off, but basically it says that if the police had some suspicion that you were a danger or about to commit a felony, they could stop you and frisk you. So that was very controversial in New York. And they said, well, it's taking care of all kinds of crime, but they're saying, but they're targeting minorities. So they did a two-way table and they said, when they stopped people of different races, did they use any force at all? Did they put their hands on them? Or did they use a high force level? And a high force level would be a taser, or they put you on the ground and put their knee in your back. So they checked those different minorities. Well, look at how many black people were stopped. 1,371, 263, and 109. Look how many Hispanics and look how many whites. It's obvious more black people were stopped than white people and more Hispanics than white people as well. So let's do the categorical. So what they said is there's two different categories in your two-way table: force level and race. Okay, and they're both categorical, which they have to be in a two-way table. So they said, let's do the marginal distributions. So if you cover up one row or two rows of the data, you can say the marginal distribution based on race is this number over their total, this number over their total, this number over their total, and you can compare it to the whole group over the whole total. So if this percentage comes out to be bigger than this percentage, you can say, oh, well, that might look like there is some kind of association between force and race. So here's their marginal distribution by force. And I'm not sure why that's black. You'll have to watch the video. He's got the numbers showing. And here's the marginal distribution by race. So when you cover up the force column and all you see is the names of the races, then you're doing marginal by race. If you cover up the race column and you can't see the names, then you're doing the marginal by force. So whatever words are gone, the marginal is the word showing. All right. So then the condition of given is, well, what percent of people received force given they're black? So when you say given they're black, you have to say, if I'm only worried about the black people, then I would say given they're black means I only looked at the black column. So the percent of people who received force, you wouldn't say this number. You'd either say the hands-on or the higher force. You could either add these two together or you could do them two separately and then add them. But that's what the marginal distribution is. The condition of force given you're black means I'm only looking at the column that says black at the top. So if they say what percent of people use force given they're black, given they're white, given they're Hispanic, you would only look at each column one at a time. So the no force was 1,371 over 1,743. The hands-on would be 263 over 1,743, and the higher force would be 109 over 1,743. So at this point, you're probably thinking, I wonder what she's going to come up with. I wonder what the data is going to show. Well, a television commentator said, hey, police had no force interactions with 260 white specks, but they had no force with 1,371 black suspects. So that says to me that there's not a favorite among the races, because more people who are black didn't get force than white. Well, I know you're thinking, well, there's more black people in the table. So what they did is the bar plot, and this really puts things to light. Remember, all bars should add up to 100. So if I stacked the orange and the gray on top, all three bars would come to 100. Well, guess what? The white has the highest blue bar, which is no force. That's no surprise. And then the orange, it looks like the highest is in the Hispanic bars. And then the gray, it looks like maybe there's more. Yeah, you can see this is the lower one of the two. So there's your segmented bar where they stacked them. I prefer the segmented bar to the bar. And now they're saying, let's use some comparative language, like a higher percentage or a lower percentage or similar percentage. So comparative percentage isn't this number is this and that number is that. It's percentage comparisons, because that's the true association. So I want you to go ahead and do the Desmos activity. It's already linked in your classrooms based on what we've just done. And I just want you to say, does our data provide enough evidence to prove that New York police are racially biased in terms of the use of force? Why or why not? And you should be able to look at your segmented bar charts. You should be looking at your percentages that you got in the marginal distributions, and you should be able to make some good clarifications. A lingering discussion. Well, that's the one we just saw. Okay, now for the look back, when I ask you which are categorical, you can circle categorical and then you can leave the quantitative out. So for chapter 2, there are like 6 questions, but they have multiple parts. So which are categorical? Age, weight, area code, first name, last name, circle the ones that are. If I ask you to create a bar chart, you need to do these as well, remember we did the bar chart where we had the frequencies on the side, so you would go up to 8 on the y-axis, and then you would have on the x-axis China, Japan, France, Spain, and they would be proportionally tall compared to how many numbers. Now for this one, they wanted a segmented bar chart, so remember those percentages go to 100. I know this is a very sloppy chart, but the percentages should go to 100, and you should tell me what they are for non-smokers and for smokers based by gender, so it should say male and female on the bottom. So when you're doing it by gender, then you need to have the gender as your x-axis values. This is what we call a back-to-back stem and leaf. So what we did is we said 9, 8, 7, 6, 5, and 4 are the stems, and the women's leaves are on this side, and the men's leaves are on this side. So for the 92 man, he goes over here, the 2. And for the 95 woman, she goes over here. But the stem is right here in the middle. Okay, so number 5 is a very detailed thing. It asks you to create a histogram for these numbers, a box plot, a mean, a standard deviation. Those are all in your 6-number summaries, right? So you should be able to get them. And the range in the IQR, remember the IQR is Q3 minus Q1. And then you're going to use SOX to answer number H. Please don't just say one thing. If you don't tell me shape, outlier, center, spread, I'm going to feel like you didn't do this assignment. And many of you on the Frappy left off reams of the SOX parts. Okay? And number 6 says, well, what if we take the number 89 right here and we switch it to 100? Regenerate all of that. So how does it affect the mean, standard deviation, median, range, and IQR? So those are the questions you have in the look back. You do not have this worksheet. I thought it was cool. And then I left some test review questions in that you might want to think about. So some of these will really help you see what my tests look like. There are multiple choice for the first part and then the free response for the second. And all of these answers should be back here. So you can actually check for these answers, and this will help you understand if you've got it right. So that's all I have. I'm going to sign off. I don't think I have anything else to say. Please meet deadlines and don't use email to me unless it's a non-homework question. Homework questions should go in the chat in that topic. All right. I will see you guys next week when your test is due. Please keep me informed of any questions you have.